All right, here we're going to determine the domain and range for the function graph below with that blue line, and use that information to state the domain and the range of the inverse function. Then I'm going to sketch the line y equals x and estimate the location of two or more points on the graph and use those to graph the inverse function on the same grid. All right, so one sentence at a time here. First, let's determine the domain and range of the function graphed. So domain is all the possible x values. So all the x values that are covered on this graph looks like it goes from not including 0, so x will be greater than 0, but not equal to. Or you could use interval notation, same thing. I'll give two possible answers. Both of these would be correct. You could go from 0, open interval, because doesn't include 0, and it goes to infinity. Again, open, because you can't reach infinity. And then the range is all the possible y values. So y goes all the way down, and it's going to keep going up. Even though it's going up very slowly, it eventually covers everything. So that goes from y is element of all the real numbers, or you can say y is in the interval negative infinity to infinity. All right, second part here. Now we're going to use this information to state the domain and range of the inverse. So with inverses, x's and y's all switch. So now my inverse, the domain, so I think this needs a name. Let's call it f inverse, and we'll call this first function f. So our f inverse function, the domain, becomes the range. So x is all the real numbers, and the range became the domain. So now the domains become the range. So the x's turn into y, so all y is greater than 0. And again, if you choose, you can also use interval notation. You do not need both. This is just for showing a few different representations of the same thing. Okay? So it's this or this, this or this. Let's see, what's the next step here? Now we're going to sketch the line of y equals x. I'm going to do that with the straight tool. And I'll just do, that's where, so -5 equals -5, -4 equals -4. So all those y's equal x's points. So right where x and y have the same value is that purple line. And I know that we need one more color here. Let's get some green. Estimate the location of two or more points on the graph, and use these to graph f inverse. So for example, here's one point at x equals 1, y equals 0. So the inverse function will have y equals 0, x equals 1. That x and y switch. And then we have a point here at x equals 5, y equals almost 3, but not quite. So we'll go to y equals 5, and x is almost at 3, but not quite. And you can see that shape. Also, there's an asymptote at x equals 0 for the original graph. So that means the inverse will have an asymptote at y equals 0. So you see this shape flip over. It's not very good. Sorry. I'm in math, not art. Flip over that y equals x line. And there's our final answer.